Molecular formulas build on empirical formulas because a molecular formula is different than an empirical formula in that it represents the actual number of atoms in a covalent compound not just the simplest ratio. So remember, for ionic compounds, the empirical formula is always going to be the best representation of the ions in the formula, because ions, because they have oxidation numbers, can only combine in one specific ratio. However, covalent compounds with the nonmetals sharing electrons with other nonmetals, the same two elements can combine in several different possible ways. So the simplest ratio doesn't represent the actual number of atoms in the covalent compound. So what do we need to find a molecular formula? You need two things. You need one, you need the empirical formula. You do need to know what the simplest ratio is. Okay, and secondly, we need the molar mass of the molecular formula. Now we can find molar mass of an unknown compound in several different ways that are not going to be delved into in the scope of this course. What are we going to do with these? First of all, we're going to find the molar mass of the empirical formula. This is what we're going to have to do. Okay, and secondly, we're going to have to find the multiplier. Okay, you say, well, what's the multiplier and how do we find it? The multiplier is going to be molar mass of molecular formula over the molar mass of the empirical formula. Okay, so we're going to see in just a little bit what are we going to do with this multiplier once we have identified what it is. Let's look at an example problem for this. Okay, so here's our first problem. It says we're going to determine the molecular formula knowing that the molecular mass is 132.16, and they give us the empirical formula, C2H4O. Okay, so we have the two pieces of information that we need, which is the empirical formula. Remember, this is the simplest ratio. So 2 carbons, 4 hydrogens, 1 oxygen is the simplest ratio. And we know the mass of the actual or molecular formula. Remember, our first step is we're going to find the molar mass of the empirical formula. Okay, so you know how to calculate molar mass now. We have 2 carbons, The molar mass of one carbon is 12.011. We have 4 hydrogens in the formula. Molar mass of one hydrogen is 1.0079. And we have 1 oxygen. And the molar mass of oxygen is 15.999. Okay, so we're just going to run these numbers into our calculator here. Okay, so 12.011 times 2. This is 24.022. 4 times 1.0079 equals 4.0316, and this is 15.999. Okay, we're going to add all those numbers up. Okay, and that adds up to 44.053. Remember, we got 5 sig figs. Okay, part 2. We're going to find the multiplier. Now, the multiplier is a whole number. It has to be at least 1. Right? And it can go up to pretty much any number. Now, you're not going to get huge numbers here, but it will be a whole number. That's the key. Now remember, we said that this is molar mass of the molecular formula over molar mass of empirical. Okay, you have to be given the molar mass of the molecular formula. Here it is in the problem, 132.16 over the molar mass of the empirical formula. That's the work we did right here. Okay, so now we're just going to do a little division. We're going to poke those into our calculator. 132.16 divided by 44.053. That's 3. Okay. So then finally, what do we do by with the multiplier? Well, you multiply the multiplier. What are we going to multiply? We're going to multiply the subscripts in the empirical formula. So we're going to take 3 times C2H4O. So I'm going to multiply every subscript in the formula by 3. So this will become C6H12O3. And this right here is my final answer. This is the molecular formula. The molecular formula is always a multiple of the empirical formula. The multiplier tells us what the multiple is. It is possible it can be 1, in which case the empirical and the molecular formula in that case are the exact same formula. Doesn't mean you did it wrong, it just means that the multiplier in that case is 1. Multiplier could be 2, 3, 4, 5, it just depends on the problem. But remember, the multiplier has to be a whole number. You may have to round a little bit here, but it should be very, very, very close to a whole number. If it's less than 1, you've got these numbers upside down. That's a clue for you. Okay, and some of the work that you're going to do today, you are going to do problems exactly like this. However, in a couple of the problems on one side of the worksheet you're going to work on today, you will see that you're going to have to find your own empirical formula using the steps that we discussed yesterday in order to determine what is the empirical formula so that you can then find the molecular formula. Good luck and happy calculating!